Okay, our last day of this unit, which has been kind of a fun one. The top end of a 4-meter ladder is sliding down a vertical wall at a rate of 0.25 meters per second. So in math class, everything is perfect. This wall is perfectly straight, even if we don't draw it. So, and of course, we can assume it meets at right angles. So it's a 4-meter ladder, and it is resting against this wall. It's sliding down the wall at a rate of 0.25. So we have this distance. I'm just hesitating because I use the letter x here myself. So the height here, I know that dx dt probably should have used y to be consistent in my own brain. But anyway, negative 0.25 meters per second. Okay, what else do we know? If theta is the angle formed by the ladder and the floor, what is the rate of change of theta? So we want d theta dt in radians per second at the instant the top of the ladder is 3 meters above the floor. So when x equals 3 is what I'm looking for, that moment as it's sliding down the floor. So like in our questions before, we need to come up with an equation that relates the things that we're looking at. So we're looking for an equation that relates theta and x. So I have sine theta equals x over 4 since I'm in right-angled trig. So if that's my relationship, I want to take the derivative of both sides because I'm looking for a rate of change. So we're marrying that rate of change business from last unit with our understanding of trig functions from this unit. So derivative of the left side, I'm taking the derivative with respect to t. Derivative with respect to time. Okay, so the derivative of sine is cos. But the letter doesn't match, nor is it even in the same alphabet. So we do d theta dt, the guts, equals. The derivative of x over 4 is a quarter, but x also doesn't match, so the guts of that one would be dx dt. I know dx dt, it's negative 0.25. Or negative a quarter. I could find cos theta at that moment. Cos theta, so at the moment that it's 3, and I know that that's 4, I could find cos theta. I would have a little bit of work to do. Okay, so if I want cos theta, I need to find this value. 4 squared equals 3 squared, I'm going to call it a, plus a squared. I have 16 subtract 9 is a squared. A is the root of 7. So cos theta is root 7 over 4 d theta dt. So we've been asked, what is the rate of change of theta? So d theta dt is what I'm looking for. I have negative 1/16. Divide both sides by root 7 over 4. I end up with negative 1 over 4 root 7, or approximately 0.09 radians per second. The other problem that we're going to look at today is to find the local maximum and minimum. So we're also looking at last unit at our optimization unit and finding those local max and min. So we need to find the turning points and set our derivative equal to 0. So the order that I tend to do things is to consider my endpoints first. So consider my endpoints. I want to know my function at x equals negative pi. Or I want to know the value of my function at x equals pi. So at negative pi, I have negative pi plus 2 cos negative pi. I'm going to type that into a calculator and I get approximately negative 5.14. The other endpoint is at pi, so I have pi plus 2 cos pi. Again, I end up with approximately 1.14. So there's my two endpoints. I'm going to consider the extrema and then make my decision. So for the extrema, I'm looking for those turning points when my derivative is 0. My derivative is, let's go. So the derivative of the first part is 1. The derivative of the second part, so the derivative of cos is negative sine. And no interesting guts. I want to set that equal to 0. So when is 1 plus, or sorry, negative technically, 1 subtract 2 sine x equivalent to 0. That's when 2 sine x is 1, or sine x is a half. When does that happen? At pi by 6 or 5 pi by 6. And I'm just thinking in that range from negative pi to pi. So I need to check in my function at x equals pi by 6. And I need to check when x equals 5 pi by 6. So at pi by 6, my y value is approximately 2, and I'm cheating away here. And it's approximately 0.89. So I have found my maximum. I need to scan those 4 values. That one, that one. Where do they go? Here. This one, and this one. So my maximum is 2.26. When x is pi by 6. And my minimum is negative 5.14 when x is, where'd you go, negative pi.